thing we're going to do is look at some of the fundamentals for data visualization using R. So we're going to look at the same data set that we looked at before. Once again, this was a study done at Fordham where we looked at whether people would prefer to take advice from human experts or statistical algorithms when making predictions about different subjects depending on how far into the future the event was. So once again, I'm going to clear my working environment to start. I'm going to set my working directory and I'm going to read my data in using read.csv. This time I'm adding this extra argument, strings as factors equals true. What this does is it just defaults anything that isn't a numeric variable to a factor as opposed to a character variable type. And the difference is just that a character variable type doesn't actually have any inherent information. It just gets treated as random text, whereas a factor has a set number of levels and R treats it as a categorical variable essentially. So we can look at, once again, the first 6 rows of our data. We did this in the last video. This is the same thing we saw before. And once again, here's some detail about some of the relevant variables. So we have the participant ID, the month, which is how far into the future the item looks, domain, which is the item subject, either economics or politics. Stats classes is how many stats classes someone's taken, and RESP is the dependent variable, which is whether they prefer machine advice, which is high values, or human advice, low values, and it ranges from 0 to 100. So base R, without any extra add-ons, has some useful plotting features, and these are conveniently called often with the plot function. And so we can use this to try to figure out, or when we use the plot function R, we'll try to figure out what type of plot you want based on the types of variables you entered. So if X is a factor variable, which again is a categorical variable, you'll get a box plot. And if X is numeric, you will get a scatter plot. And so Y should always be some kind of numeric variable. And so here we called plot for domain and RESP. So domain is a factor, economics or politics, and RESP is numeric, ranging from 0 to 100. Once again, with higher values representing more preference for statistical algorithms versus human experts. And so here's our box plot. We see for economics questions, the results tend to be higher values, and for politics questions, the results tend to be lower values. And so here we instead use 2 different numeric variables. So here we use age for X, and we once again use RESP for Y. And so because these are both numeric, R outputs a scatter plot. We can tweak our plots and customize them with several arguments. So we can add axis titles with the XLab and YLab arguments, a plot title with the main argument. We can change the color with the COL argument. We can change line types, point shapes, and the limits on the X and Y axes. And note that we put these inside the this concatenate, this C function. So here I have customized my scatter plot so that it goes from 0 to 100 on the x-axis. The points are blue, and here's how I change the x-axis. I say xlim c 0 to 100. I made the points blue. I changed the axis labels, so on and so forth. So that's all we're really going to talk about with R's basic plot functions. These are good for sort of all just sort of like general use, but they're not the most flexible in the world. And so while you can do a lot with the base R plots, the ggplot2 package has sort of become the gold standard for data visualization in R. And it has a little bit more of a learning curve, but it's much, much, much more flexible, and I highly recommend people learn it. So ggplot2 uses what's called an aesthetics-based syntax. So most ggplots will start with this sort of skeleton where you call the ggplot function, you name the data, and then you use this AES, which is for aesthetics. And here you name what each axis is. So X is the x-axis and Y is the y-axis. And then once you have that skeleton, you define the plot by adding more elements with the plus and geom arguments. And geom is short for geometric element. And we'll take a look at what this looks like. So here, again, ggplot is an external package, so we have to install it the first time before, if we've never installed it before. Once it's installed, you have to load it up every session you want to use it. So here I am generating the same box plot I did before, where the x-axis is domain, the y-axis is RESP. And I do this by just calling plus, by defining my skeleton here with the data, the x and y axis, and then I add geom box plot as an extra argument. And here we get the same box plot that we saw before. It looks aesthetically a little bit different, but the actual plot itself is the same. And here we can do the same thing. We can get a scatter plot by calling geom point here. That will ask for a scatter plot. And so this is the same as the scatter plot we saw before with base R as well, where the x-axis is age. So while ggplot2 is a little bit more complicated for simple plots, it makes it much easier to add custom elements, which is one of the great things about it, and to manage more complicated plots. So it's also great for making plots nice to look for publication. So in this example, I'm going to show some plots that are factorial plots that are grouped by color. We can group other ways, such as line type or point shape or stuff like that, but color is just a bit prettier, so we're going to do that here. So here, what I'm doing is I'm using the fill argument to say that I want different colors for each different month, but otherwise this is the same box plot that we've seen. It's just that instead of one box for each domain, we get two, which are shown in the legend here, one for each month. And once again, the only difference here is I added this fill equals month. Fill represents the fill color. So the red plots here are for the long-term questions, and the blue ones are for short term. So we just get this nice factorial plot with two boxes for each domain representing the 2 months. And we can do the same thing for scatter plots. Instead of fill, I call color here, and that just separates the point colors. So again, the red dots are economics and the blue dots are politics, while the x-axis is age still, and the y-axis is the dependent variable. We can also change the labels and aesthetics using various extra arguments in ggplot. It's a little bit different than base R, again, because we're adding things on with the plus instead of adding extra arguments inside the plot function. So here are some examples. The LABS labs can help set axis labels and titles. The theme BW argument gets rid of that sort of funky gray background that's the default in ggplot. The theme argument on its own has allows for several aesthetic tweaks that you want to make, and then scale X continuous or scale Y allows you to modify the axis scales. So this is sort of like a nice, long, complicated looking chunk of code. Maybe if you've never seen something like this before, let's go through it step by step. We're starting here with our skeleton once again. So we have our data. We have our x-axis is age, our y-axis is the dependent variable RESP, and the color is domain. So this is a factorial plot looking at the relationship between age and the dependent variable separated by the item domain, economics or politics. That's the core of our plot. So then I'm going to add plus and say I want it to be a scatter plot by asking for geom point. And then I'm going to add another plus, and in this LABS function, I am going to change the names of the x-axis, the y-axis, this color is for the legend. So this is you change the legend name by matching it to the factorial call here. So color is how we're separating things. So if I want to change the legend name, I put color here. And then finally title, I'm going to just give this a general title of scatterplot. So that changes the axis labels in the legend title. Then I'm going to call theme BW after another plus to get rid of the gray background. And then I'm going to move the legend to the bottom by calling legend position inside of theme. And then finally, I'm going to scale the x-axis so it goes from 0 to 100. And this is the resulting plot. So we can see it has all these things I asked for. The legend's at the bottom. We have a white background. We changed the labels to look the way we want them to. And here's the plot again, a nice, pretty plot. There are also some packages with convenient wrapper functions that help us plot model results. We can do all of this stuff in ggplot, but it gets a little bit complicated to do it by hand. So these are some helpful functions that just will do it for us. So one package that does this is called ggeffects. So I'm going to load that up here, and I'm going to fit a model. This is similar to what we saw in the last video. So this model looks at the interaction between domain and month with age as a covariate. And then let's say I want to get the model predicted results with respect to both domain and month. So I can call the ggpredict function, and I specify the two terms I want. So here, the first thing you specify inside of the terms is going to be the x-axis, and then the y-axis is going to be the factor determined by the color or the legend, which we'll see in a sec. So once we create the ggpredict object, we just put it inside of just regular plot. So I'm just going to plot this, what I just made, and then after that, I can do it. I can add any ggplot arguments I want onto this call. So so here I'm changing the x-axis to be domain, the y-axis to be preference, color is month because month is what we're separating by, and I'm just deleting the title here. So there's no title, and I'm changing the scale of the y-axis to go from 0 to 100. And so you see this gives us these nice points and error bars. So here we see on the x-axis we have the economics and politics factors. On the y-axis we have our dependent variable as always, and then it's separated out by month. So we see the two different months for both economics and politics. So if we use a continuous predictor instead, we can do the same thing, and this will give us nice line plot. So here I'm separating by domain while the x-axis is age. And again, I'm doing my aesthetic tweaks. And so this gives us a nice line plot with this confidence band. So here we see the relationship between age and preference separated by the two factors, politics and economics. So we see in general, people prefer the algorithmic advice for economics, but there's a little bit of a negative correlation between age and preference either way. And if we use a continuous moderator instead of a categorical moderator, we have to specify the levels that we want to view inside of square brackets. So for example, let's say we wanted to look at the relationship between domain and the outcome variable predicted by our model. But we want to look at how it's moderated by age. So here we're going to look at the predicted results for ages of 25, 35, and 45. So you can always specify different values in here, and often you'll see this be something like 1 standard deviation below the mean, and then 1 standard deviation above the mean of whatever your moderator is. And so here we get this plot. So we get, again, our factors on the x-axis and separated out by the 3 age levels that we call.